Hello, I'm Brad from BlastOne. I'm going to show you how to set up one of our blast machines. Over here, this is an air dryer. This is important because cool, dry air is very important to get high productivity when we're blasting. Moisture in compressed air will often drop blasting performance by about 15 to 20%. So we have a ball hose coming from our compressor, coming into the inlet of the air dryer here. We've got a radiator here which is drawing ambient air through the stream of compressed air which is coming through the top here. That's cooling our compressed air. Comes into this drying tank here, which causes air to expand when it comes in the bottom here and slows the path of the air down to a very slow speed as it rises up through the tank, causing moisture to drop out of the air. That then will come out of one of the outlets here and into the blast machine. Let's go and have a look at the blast machine in more detail. Right here is the outlet to the air dryer. This will feed the blast machine through a 2-inch ball hose. We recommend 2-inch. I'll talk about that a bit more later. This is a ball valve. The way to tell if a ball valve is on or off, if the handle is 90 degrees to the direction of the air travel, that tells us it's off. When it's in line with the hose or with the air travel, that tells us it's normally on. Unless, of course, the ball inside has become separated from this handle. Let's close that off. So we have here a safety device called a whip check. This is a hose restraint device. This here comes around the other side of the coupling, comes onto the ball hose here, and is designed to restrain the hose should the coupling ever separate from the hose. If you ever see this in a U shape like that, that's actually the incorrect way to fit a whip check, and that must be strung out along the hose like so. This is another safety device called a coupling lock pin. This here connects the two couplings together. This coupling here is called a Shore-Lock 2-claw coupling. With any claw type of coupling, we must have a coupling lock pin to ensure that those two couplings are locked together. That fits up like so. That will ensure that whenever this is pressurized, that it doesn't suddenly disengage from each other and cause someone an injury. So we've got two safety devices, whip check and a coupling lock pin. Coming through to the blast machine, this is the inlet to the blast machine. This is a different type of coupling now. This is called a spud, which is a screw type of coupling, and this does not require a coupling lock pin. Again, we have a whip check safety hose restraint. This must be on any hose over a 1-inch diameter. Must have a safety whip check. Come through, this is the inlet to the blast machine. This is a pressure relief valve. It's generally set at the pressure of the maximum pressure of the blast machine. So if the compressed air pressure inside the vessel ever rises above the rated pressure of the blast pot, say it's 150 psi, this will exhaust and depressurize the blast machine, preventing any possible failure. This valve here is our on and off valve. This will turn the blasting air on and off. So when we pull our Deadman trigger, as I'll show you soon, this valve turns on and off, turns the air supplying the blast hose on and off. This valve here is what we call our choke valve. This will turn when we're blasting. We can close this or partially close this to restrict the air coming into the blast hose, which then puts more pressure into the pot than is in the blast hose. So we've got a pressure imbalance, so there's more pressure in the pot than in the blast hose, and that will force any blockage to clear. This here is what we call our control valve, and this is supplied by our Deadman lines. The red hose here is what we call the air on to our Deadman handle, and then the air coming back from the Deadman handle comes on this green hose into the control valve. This here is our metering valve. This is called a Thompson valve. This is a very good valve because it can very, very accurately adjust the abrasive metering. It's controlled by turning the knob like that. It's about 10 complete turns from fully closed to fully open. With BlastOne Speed Blast garnet abrasives, it's generally set at about 3.5 turns out from fully closed. So we wind this fully in, then we come back out 3.5 full turns. That's generally about the right mix depending on the nozzle size. And lastly, this is our muffler and the exhaust of the blast machine. So when we need to exhaust, when we finish blasting and need to exhaust the blast machine, we close the ball valve and open the exhaust, and that will ensure that the blast machine will depressurize. This is the blast hose. This is connected to the front of the blast machine, and that supplies the blast nozzle. Over here we have the breathing air filter, supplied by a 3/4 inch or a 1 inch line coming from the air dryer. Comes in here. It's got a cartridge inside here which removes any odors or any oils or any water, and then it comes up through the regulator. We can regulate what pressure we've got going out through the breathing air line to the blasting helmet. That ensures that the blast is only and always breathing pure dry air. This is the front of the blast machine now. This is where we connect our blast hose on. Again, we've got a hose restraint called a coupling lock pin. Got our whip check device. This blast hose is a 2-claw coupling. It's a specially designed coupling to fit on the outside of the blast hose so that it doesn't wear on the inside. This connects up onto the front of the metering valve, clicks into place. We must put a coupling lock pin in to ensure those two couplings are firmly together. Again, we've got a whip check to ensure that if this ever does separate from the hose, this hose is caught. This is called a lid and screen. Lid to stop any rain getting in. A screen, so when we load it with abrasive, it will pull out any foreign particles. Let's take a look. This lid and screen has an inside lip and an outside lip. So the inside will go on the inside of the pot, the outside on the outside of the pot. That just makes sure that any abrasive we load up doesn't fall around on the outside of the pot. Okay, this just shows you how the abrasive falls down into the inside of the blast machine. When we pressurize our blast pot, this valve here will pop up and seal against this ring inside here, sealing the pot and allowing the pot to pressurize. I'm just going to explain the Deadman system in a little bit more detail, how it actually works. This line here comes out of the side of the auto air valve, comes up into this bronze abrasive separator. That will take out any small particles of abrasive before it gets into the more detailed parts of the Deadman system. Comes in here. This is called a black control valve. When the air comes in here and feeds this red line to the Deadman handle. So that supplies air to the Deadman handle. It's red means its air is on the whole time. When we pull the Deadman handle, that gets air to come along, back along this green hose into this control valve. The shuttle in this control valve moves to the left, allowing air from this part to travel through the control valve and into this second black line here. This second black line here supplies air into this, the other side of the diaphragm in this automatic air valve, which pulls the air valve open, allowing air from the main bull hose here to flow into the blast machine. At the same time, this line is also opening up our Thompson valve here, which causes abrasive to flow. This red line here is very important to be connected up to the right side of this control valve. We made it easy by making this red line a 1/4 inch and the green line a 1/8. If they're fitted up around the other way, the blast machine will not work correctly. So our blasting helmet, it's called a Nova 2000 blast helmet. This is what we recommend in most blasting applications. It's fed by our breathing air line, which is coming from our breathing air filter. Here we have a special coupling called a dual action coupling. It requires 2 actions to get that coupling apart. You've got to push the hose and pull back the coupling for it to come apart. It just pushes together like so, and we pull our coupling on like so. This red item here is called a cool air tube. That creates a vortex with the compressed air, cooling the air before it feeds up into the blast helmet. On this blast helmet, this is where we fit our lenses. The lenses clip onto the inside of this helmet here. Clip onto the 2 tabs. Closes and fastens Where's the buckle? Okay, this is the other end of our blast hose. This is where we do all our work. This here is our Deadman handle. Again, it's supplied by the red and green Deadman lines. Red hose is pressure in. If you take a close look at this, the right hand side of this Deadman handle, it's got a little arrow in, meaning that's where the air comes. When we pull and activate this Deadman handle like so, it causes air to come through the valve and back along the green line, firing up our Deadman. So as soon as we've put our finger on that little button there, clipped it down and start blasting, we're in action. We're blasting.